Becca. Coincidentally, I also work at Formidable, but will not be starting for another week-ish, so hold your questions until then, but I look forward to starting. So I'm talking today about React state. And it turns out that the world is full of states. Menus open and close, messages appear and disappear. Lots of things need to happen at once. Some things are automated, and things go wrong. Sometimes things don't quite work out as expected, and these are called state conflicts. Our web applications are no different. As I've been working in this field and researching for this talk, I've come across many different kinds of people as it relates to state management. And today I'm going to talk about 3 of them. First of all is the newbie. Maybe you're new to software development or just to React, or maybe you've been using React for a while, but you're new to using it to solve more complex problems that you can't solve with a default Create React app or Gatsby setup. For you, state management in React can seem overwhelming, and just Googling it leads to thousands of seemingly contradictory search results. And without experience using all of these different tools and strategies, it can be hard to know where to start. Second is the person who I fondly refer to as the loyalist. This person's attitude can best be summed up by, if it ain't broke, don't fix it. Perhaps you've been using Redux since 2015, and it works just fine, thank you. Maybe you've been working in the same application for all these years, or maybe you just have a favorite setup that you use every time you bootstrap something new. But then you hear all these other developers talking about MobX and Apollo and hooks and context and state machines, and you just don't really get it. What do all these tools have to offer you when you already have something that works? You sometimes feel like the frustrated old man or woman who just doesn't understand all the hype. I get you. Or maybe you are the explorer. If you're like me, you've tried everything and formed a lot of opinions about what you like and what you don't like, but you sometimes struggle to articulate why you have these opinions to teammates and other stakeholders. This, to me, is both the advantage and disadvantage of consulting. Even as I was preparing for this talk, I ran into kind of a tricky situation where I disagreed with a teammate on the best way to manage the state of all of the forms in our application, which if you've ever tried to do that can be a pretty daunting task. Honestly, I just wanted to take him down. I wanted to use my superior knowledge to prove that I knew the best thing to do. But it turns out that it just doesn't really work that way in a professional context. But no matter which one of these categories you fall into, in a world of libraries, React APIs, and design patterns, it can be easy to get overwhelmed by tools and lose sight of the actual problem that we're trying to solve. The purpose of this talk isn't to teach you how to use context or hooks or Redux or Flux or any other state management strategies, but it is to help us clarify the problem, explore some solutions, and then make decisions with an ever-increasing array of options, and then ideally involve other people in those decisions. For the purpose of this talk, I'm going to be talking about a tic-tac-toe application. First of all, because I'm one of the world's leading experts at developing over-engineered tic-tac-toe applications, but also because I think it's a good example of some of the state management problems that we encounter on a day-to-day basis. So in this application, a player can make a move. They can play against a pretty dumb computer player, and it will alert you if you win the game. So what is state? Well, in a React context, React has a state API that we can access using setState or useState. I'm sure most of us in this room are pretty familiar with the basics, but we're going to talk a little bit about them before we move on to some of the more advanced things. So this API allows us to make asynchronous changes to the state of our application and then update our component through the process called reconciliation if it has been changed. So that's basically the component will re-render if the props or the state have changed. The React docs refer to this as local state. So let's take this modal, for example. In a class component, I can initialize the state, update the state using setState and an updater function, and then render the component based on the current state. And likewise, in a functional component, I can use the useState hook to return the current value and an updater function. I can then use this updater function to update the states and render based on the current value. If you're looking for a way to store user input or change the state of the DOM, this is where you should start. This is pretty simple, and there's no need to overthink it. But as our application grows and changes, if we're using only React state, a couple of problems begin to emerge. The first problem is called prop drilling. In a really simple application, we may have only one layer of nesting between the application root and the lowest level components. So in this case, let's say I have a logged in user that looks something like this. In my top level component, I can fetch the logged in user, update this user in state, and then pass it into my child component. In my child component, I can display the user's name. But what if I refactored this to add a greeting component rather than just rendering the name in the component? Now I'm passing the same prop through another component. Hold on. As our applications become more complex, we introduce more layers of nesting. And as we introduce layers of nesting, we are creating more layers that we might need to pass our state data through. And as you can imagine, this can get pretty hard to maintain. Another problem we run into is repetition. So now let's say I have two modals in my application. I have the one that I just saw, and I have an error, which this happens sometimes. I need to let the user know that something went wrong. Now, first of all, if you want to know how to drive me insane, use the same state variable in all of your views, but make the name just slightly different each time. I just love this. I'm a very nice person, but I will git blame you and send you irritated emojis. So this is not ideal, and I like to avoid this. But as annoying as this syntax is, the bigger problem is the complexity of the state when it's delegated to lots of individual views and the potential for state conflicts. With every new state variable I add, we exponentially increase the number of different states that our application can be in. For example, if I have two modals, how do I make sure that they aren't both visible at once? In both of these issues, in prop drilling and repetition, a bigger problem starts to emerge, which is the problem of managing state across multiple components. When my state management is local or contained in a single view, how do I gain access to the state outside of this view and keep the whole application in sync? Well, this is where we start talking about global states. Global states is state that is accessible in any component in my application. There are also a few options in between, which we might call semi-local or semi-global states. For the purpose of this talk, I'm not really making a distinction, but basically this is state that is shared by a subset of components, but not by the entire application. So this brings us to 2014, when Facebook first introduced us to Flux architecture. Flux architecture and Redux, its most popular implementation, gave us a set protocol for getting and updating global states, which is referred to as the store. We have functions that are called actions and reducers that are able to systematically update our state globally and then pass it into the view, which is then able to call an action to kick off that process all over again. If I were using Redux for my tic-tac-toe application, I would be updating my state with a set of actions and reducers. I might have an action that declares a type of state updates. In this case, it is a make move action that declares a payload, which is the index of the spot. And my reducer basically looks for the type of the action and transforms the state based on the type and the payload. I will also note that there are some functions in React that help us to interact with this store. So I have a function called map state to props that takes the state in the store and maps it to my component props. And I have a function called map dispatch to props that takes my dispatcher that will change the states and pass it into a prop. And then I can connect it to my components. Flux architecture excels at allowing us to track and log state changes. Because we have a single source of truth, we have a single record of everything that's changing inside our application. But even just using Redux for this small application, there are a few drawbacks that I've started to notice. The first and most commonly cited drawback is a boilerplate. Having to write an action and a reducer for every single state transformation can create a lot of overhead. But for me, the bigger problem is a little more subtle. Redux forces us to be intentional about which components are connected to the global states and which components are presentational or they only accept props from their parents. This separation of concerns is great, and it's generally really good design if you are designing components. But with Redux, there's also another separation of concerns that I don't love quite as much, and that is the separation of concerns between a component and its own state. And in some cases, that can create too much abstraction. For example, if the state of this game is completely dependent on the props that are passed in from Redux, then I can't interact with it in isolation using a tool like Storybook. Also, for me, testing is really important. But when I'm writing unit tests for this component, I'm kind of limited in what I can test. For example, in this example, I can test a click event. So I can pass in a callback and test that that callback gets called when I click on a spot. That's a pretty basic test, and some people might argue that it doesn't tell us a whole lot. If I want to know a little more, I can test my Redux reducer by passing in the initial states, calling the reducer with an action, and then testing to make sure that my state was updated in the way that I expect. This gives me a little bit more information, but I can't actually test how a user would interact with this component, unless I break the rules of testing a fully connected application, or unless I break the rules of testing a connected Redux component, or I use a tool like Cypress or Puppeteer to test the fully connected application. Oh no, what happened? There we go. So I might actually want to test, that a user can use this component. And I want to say, if a user clicks this button, I expect the content of that button to actually change. But right now, I can't test that. All right, I'm not going to use this clicker anymore because it's doing weird things to me. So, moving on. In recent years, we've recognized that using Redux for more localized concerns like form management results in performance issues and unnecessary overhead. And even in places where it still excels, like API caching, many of us have started using tools like GraphQL and Apollo that give us a lot of this caching for free. So fast forward a few years, and we've started to realize that keeping our state local or semi-local isn't such a bad idea. But how do we do this while still reducing some of the aforementioned problems like prop drilling and duplication? Well, first we came up with patterns like higher order components and render props. These are both design patterns that we've come up with in order to extract our state management logic to an external component. So if I wanted to extract some of my modal logic to reduce duplication, I might create a component called a modal manager that passes down the props that update the state and tell me which modal is open to my child components. Now, this modal manager is pretty similar to what we saw before, meaning that it stores the state and it provides me a way of updating it, but rather than actually rendering my component, I'm calling my children as a function in order to pass props down. You might see this pattern if you have ever used the Apollo library that uses the render props pattern to pass down the states of the HTTP requests to the child component. These patterns give us a lot of flexibility, but even just using these two wrappers together results in something that I like to call wrapper hell. I'm not going to talk a whole lot about higher order components, but I'll just point out that one example that I used earlier, which is this Redux connect function, it uses a higher order component to wrap my component and pass props into it. But this could also be wrapper hell. That's not very pretty either. So the React API has evolved over the past few years, giving us new tools for state management. The first of which is context. Context might be considered React's alternative to Flux architecture, giving us an API with components called providers and consumers. I'm able to store my state and my helpers in my provider and then pass it into my view through a consumer. This pattern can be used for global state management if the provider is wrapped around my entire application, or it can be used for semi-global state management if it's wrapped around a smaller subset of components. This could be great if you are looking for a way to share state between components, but don't know where to start. Going back to an earlier example, if I use context to store the logged-in user, I can pass it into any child component without prop drilling. I could even use context to ensure that only one modal is open at once, reducing duplication. A context provider might look very similar to some of the components that I've seen before. It's basically a way to store my state and pass it into the consumer. This gives us state management without the boilerplate. And then, of course, we have hooks. You've already seen some hooks in this presentation, including use state and use context. Basically, the hooks API is designed to free us from some of this wrapper hell, giving us a way to access context, state, and custom logic in our functional components without introducing layers of nesting. Hooks aren't a new paradigm, but they're a new way of accessing existing APIs, like state, context, and render effects, or lifecycle events that fire on every render. For example, I could extract some of my game logic to a custom hook rather than using render props. And by the way, there's another hook that I would like to point out called useReducer. This hook allows you to create a function for updating your state using the state reducer pattern, which you might be familiar with. I'm then able to call my reducer to dispatch an action. The reducer looks very similar to what you might see in Redux, returning a new state object based on the type and the payload. This is personally one of my very favorite patterns to use right now, as it gives you a lot of the advantages of immutable states and like standard ways to update the state with less boilerplate. So now, if I switch to using a reducer or a custom hook, I'm now able to test my application the way that I want to. I'm able to click on a spot and test that the content actually updates. So the question of the year is, do you need Redux? I'm not the authority to give you a 100% answer on this, but here are some of my thoughts. Talking to people about this, a common refrain that I've heard is the complexity of Redux and how its learning curve may discourage developers from using state management at all beyond basic component states. And for what it's worth, as a little side note, while I haven't used it myself, I have heard that some alternatives like MobX are a little simpler to use and understand because they're less reliant on functional programming principles. So my conclusion is that I am going to go with Dan on this one and say, maybe not. But if you are looking for a way to manage more complex global states, I hear it's not dead yet. But please just don't use it for your forms. So in light of all of these options, how do we choose? First of all, I'm going to tell you that you don't have to choose just one. I've found that often it's good to use a combination of approaches for managing the state in my application, rather than just deciding on one and sticking with it forever. But when deciding on a strategy, think about a couple of things. First of all, what is the scope of the states that you need? If you only need access to the state in one place, like inside one component, then it should be managed locally, either with a regular component state or maybe a library to reduce some duplication. If you need access to the state in more than one component, then you may want to try context or Redux, depending on your use case and your level of comfort with functional programming. Next, is there a commonly used library that can help? A good example of this is forms, as I've alluded to before. Forms in React can be notoriously tricky when you are dealing with lots of different components and their states and how to keep all of your form data in sync. But there's really no need to reinvent the wheel every time you want to implement one. There are great libraries like Formic or React Final Form that might help you to track and update the state of your form locally. And lastly, do you see this state being repeated somewhere else? If so, you might want to consider using something reusable like a custom hook or render props or a higher order component, depending on your preferred version of React. Now, I know that most of us aren't building brand new applications all the time. But personally, one of the things that I like about these React APIs that are a little bit newer is the fact that they allow us to make incremental changes rather than introducing a whole new library or a whole new paradigm for state management. If you haven't tried patterns like context or hooks yet, I highly recommend them and encourage you to give them a shot. In the real world, I know that choosing libraries and design patterns is not always this simple. After all, we have team members and stakeholders who might have different opinions than our own. I really wish there was a magic bullet solution for convincing everyone else that our preferred set of tools and design patterns is the right one. But unfortunately, such a solution does not exist. I can only demonstrate for you how you might present possible solutions to the problem once you have identified the problem. And recognize that we're all coming from different places in our willingness to adopt these different solutions. I still have a lot to learn about working with teams to make good decisions about our code. But I would like to wrap this up by giving out a few pieces of advice, no matter where you are. First of all, keep learning from others, and don't be afraid to try something new, even if it's not the perfect solution forever. Because in our world, there is no perfect solution forever. Something is going to change, and we're going to try something new next year. And while you don't have to be the first to jump on the hype bandwagon, don't be afraid to break out of your comfort zone and try something new, even if it's uncomfortable. And lastly, learning all the things isn't necessarily the same as learning the right thing. Keep working to identify the real problems before making assumptions about the right solution. Thank you very much.